Welcome back to Unit 10 notes. We're on our last set of notes for Unit 10, which is called Series. It's 10-5, which you can find on the bottom of page 11. Now, on the bottom of page 11 is just a basic review of our recursive and explicit formulas for both arithmetic and geometric. What you have to know is that arithmetic you're adding, and with geometric you're multiplying. So arithmetic has a common difference, a d value, and geometric has a common ratio, an r value. Okay, let's go on to page 12. On page 12, we're starting today to talk about series. If you want a set of a sub 1, a sub 2, a sub 3, represents the elements of a sequence, then a series S sub n is defined by as following. S sub n equals the adding of all those elements in a sequence. Therefore, sigma notation is going to be needed. An arithmetic series has the sigma notation and the actual formula that is used for an explicit arithmetic sequence. So the steps are you're going to write the explicit form for the nth term and then rewrite in sigma notation and evaluate using the calculator. Okay, that doesn't sound too bad, so let's get right to it. Number 1, find the sum if the first term is 6, the common difference is 8, and there are 25 terms. Okay, so they want the sum of the 25 terms of a specific sequence where they're telling you it has a common difference. Well, common difference to me tells me right away that it's an arithmetic sequence. So we're going to write out the standard form for the actual formula. So it's a sub n equals a sub 1 plus d to the n minus 1. So in order to fill in this formula, I need a first term and a difference. Let's see, did they give it to me? A sub n equals, they gave me the first term, it's 6. They said the common difference is 8 times n minus 1. So we're going to do a little bit of mathematical work, and we're going to get 6 plus 8n minus 8. Put together like terms, a sub n equals 8n minus 2. So there is my explicit form or my formula. Okay, now that we know that, we're going to write it in sigma notation. All right, so we start off with a sigma notation over here. And they want to know the sum of the first, and they gave us the first, and there are 25 terms. So we're basically going from the first, we'll say n is 1, to the 25th term. Now again, you can find all 25 terms and add them all up, or you can use your calculator. So we're going to put in the formula that we're going to use to find the 25 terms and find their sum. So take your calculators out, punch it in, and see what you get. Well, hopefully you ended up with 2,550 as the sum of the first 25 terms of that arithmetic sequence. All right, that wasn't too bad. So we know how to write the formula because we've practiced that, and now we know summation, so we're actually just putting them together. All right, let's go on to number 2. The last term, which is the 16th term, is 175, and the common difference is 12. Find the sum. So this is a little different. All right, they said the common difference is 12, so I know it's arithmetic. All right, so let's see what we can do here to find a formula for this. So we're going to start off with a sub n equals a sub 1 plus d times n minus 1. Now, in order to write a formula, we need the first term and the common difference. Well, we don't have the first term, so that's going to stay as a sub 1. We have the common difference, that's 12. But they did give us the last term, which was the 16th term. So we know an a sub n, we know an a sub 16. So my n is 16. And a sub 16 is 175. So this will help us to achieve our first term. So we're going to do a little math here. Okay. So we have 175 equals a sub 1. 16 minus 1 is 15. 15 times 12 on a calculator is 180. So if I subtract 180 on both sides, negative 5 equals a sub 1. So I do now have my first term. So now we're going to write our formula. So we have a sub n equals our first term of a negative 5 plus the common difference is still 12 to the n minus 1. Okay. We're going to neaten this up. A sub n equals negative 5 plus 12n minus 12. Combined like terms, a sub n equals 12n minus 17. So there's our formula. So we're going to do our summation now because it said find the sum. All right. The first term we know now, which is n sub 1, is going to be our first term, and we know it went up to the 16th term because they gave us the 16th term. The actual formula is 2n minus 17. It could be put in the calculator. I'll give you a second to do that. And hopefully you achieve 1,360. Again, if I'm giving the answer too fast, just pause, get the answer on the calculator, come back, and make sure that our answers match. Okay, let's move on to the next page and see what other exciting problems we have to do today. Looking at number 3a, find the sum of each of the following arithmetic series. Well, we have to have a formula in order to find the sum because we know we have to do a summation. All right, so did they give us the first term? Yes, they did. So I have a sub 1 being negative 34. Did they give me the common difference? No, they didn't give me the common difference, but I could probably figure it out. What am I doing? I'm going down, so it looks like I'm going up. It looks like I'm adding a positive from a negative. 4, no, that doesn't work. Oh, looks like my common difference is 8. Okay, so now we have the two things we need to write a formula, so let's do that. So a sub n equals a sub 1 plus d times n minus 1. Fill it in. A sub n equals a sub 1 is negative 34 plus 8 times n minus 1. Negative 34 plus 8n minus 8. We're going to combine like terms and get a sub n equals 8n minus 42. Okay, so now we have a formula. So now we're going to actually write the summation. So the summation is, starting at the first term, all right, here's my other problem I have with this one. I don't know what the last term is. I have the last term, it's 86, but I don't know which term it is. So I have a little bit more figuring out to do. Okay, so let's do that down here. The last term we have is 86. So 86 equals, I don't know the term, so 8n minus 42. I'm looking for the n, the term that will give me 86. So I'll add 42 to both sides. I get 128 equals 8n. I'm going to divide each side by 8 and end up with 16 equals n. So 86 is the 16th term. So that is a sub 16. So now I know 16 is going to go up here in my summation. Put in my formula of 8n minus 42. Pause the video, put in the calculator, come back. Let's see if our answers match. All right, hopefully you end up with 416. That wasn't too bad. It had a little extra twist to it because we actually had to find our last term to see where our summation was going up to, so we only summed from the first term to that term, and we were able to figure it all out. Okay, let's move on right now to number 4. Number 4 says a theater has six seats in the first row. Okay, so that's a sub 1. That's my first term, 6 seats. And 8 additional seats in each row. So it looks like they're adding 8 seats to each row. So that's my common difference. My common difference is 8. If the theater has 20 rows, how many seats are in the theater? All right, so it's a summation because it's got a common difference. So we have a sub n equals a sub 1 plus d to the times n minus 1. So it's 6 plus 8 times n minus 1. 6 plus 8n minus 8. So a sub n comes out to be 8n minus 2. They want the sum. How many seats are all together there? That's adding them all up. So it's a summation of n starting at 1. They said they have 20 rows, so that would be my last term. 8n minus 2 is my formula. Put it in the calculator. All right, hopefully you ended up with 1,640 seats. That's how many seats are all together. All right, going now to geometric series. So we talked about arithmetic series having a common difference and using summation. So now what we're going to do is talk about geometric series having a summation, but now they have a common ratio. Now here's the cool thing about geometric series. You have the formula with the summation symbol, and you also actually have a formula, which is found on the formula sheet when you get the exam. The only thing I see is that if you're going to use the formula sheet, that's great. But you really should memorize the other one too, because you're going to need to know how to write an explicit formula for a geometric sequence. So, and you have to know how to do it with summation for arithmetic. So chances are you really should know how to do both forms. All right, so with that being said, let's take a look at number 5. Find the sum if the first term is 7 and the common ratio is 2. All right, so I'm going to do it two ways. First, I'm going to do it using summation, and then I'm going to do it using the formula on the formula sheet. All right, so in order to do this, I need an a sub 1, which I know is 7. I need a common ratio, which I know is 2. So we have to write the formula first. So the formula is a sub n equals a sub 1 times r to the n minus 1. So that would be 7 times 2 to the n minus 1. So that's my actual formula. Okay, so we'll do our summation now. It's summation of n starting at 1, because I have the first term. They want to know there are even 15 terms. There are 15 terms, so we're going up to 15. Plug in the formula 7 times 2 to the n minus 1. You can put that in the calculator, pause the video, and come back and see what you get. Hopefully you ended up with 229,369. If you didn't, pause the video again, put it in the calculator again, take your time that you have everything positioned where it needs to be, and then see if you actually get the same answer now. Okay, so now that's done doing summation way. Let's do it the formula way. If I take a look at the formula, I definitely need a sub 1 and my r, just like I need to write the other one. So a sub 1 again is 7, and my common ratio, my r, is 2. All right, so we're going to fill in the formula. We have s sub n equals a sub 1 minus a sub 1 times r to the n all over 1 minus r. So we're going to fill it in. We're going to have 7 minus 7 times 2. My n is how many terms there are, because s sub n stands for the sum of the terms. So this is the sum of all the terms. So my n in this case would be 15, because there's 15 terms, all over 1 minus, my r is 2. So you can take your time, plug that in the calculator, and see what you get. Well, hopefully you're back and you did achieve the exact same answer as we did with the summation. So now, you have to look at both ways and determine which way do you like better, the first way or the second way. And either way is acceptable to use. But what you have to remember about the second way, that this means S sub n means the sum of the terms. So you have to know how many terms you are summing. Okay, now that we've practiced that a little bit, let's move on to the next page. Taking a look at number 6a. Find the sum of each of the following geometric series. Okay, you can do it either way. I'm going to actually do it using summation. I just think it's a little easier. And then we could put it the other way too. If you want, take some time, you can do that also. All right, so in order to do this, I need the first term. So a sub 1 is 2. I need a common ratio. What am I multiplying by? Oh, my r is 3. That's not too bad. So I'm going to write the formula. A sub n equals a sub 1 times r to the n minus 1. So a sub n equals 2 times 3 to the n minus 1. Okay, that wasn't bad. All right, let's start my summation. It's a summation of n starting at 1. Uh-oh. I don't know where I'm ending. I do have the value of the last term, but I don't know what term that is. All right, well, I'm going to put my formula here because at least I know that. 2 times 3 to the n minus 1. And now I'm just going to do a little work to find that last term. I know the last term is 4,374. I'm looking for the n, what term it is, so I can use my formula and just solve for n. So I'm going to divide each side by 2. And get 2187 equals 3 to the n minus 1. I'm trying to find a variable in an exponent, so I'm going to give each side a common log because I'm really not sure what to find as a common base. Not sure if 3 works or not. I mean, I could have looked into it, but I'm going to use a common base. Okay, I'm going to run into the next problem here, but that's okay. I'm going to divide each side by log of 3. And I'm going to end up with, hopefully people got it, good, 7 equals n minus 1. I'm going to add 1 to both sides, so 8 is n. So the 8th term, so this would be a sub 8, is 4,374. So I'm going to be going in my formula up to the 8th term. So now I can put that in my calculator and see what happens. And hopefully you ended up with 6,560 just like I did. Now, let's go and see what happens if I use the actual sum formula that they give me on the formula sheet. So that would be S sub n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. I have the first term, it's 2, minus 2 times 3. I now have the last term, but again, if I would have started off with this formula, I would have had to do the exact same thing by trying to find the last term. Now, which would have been hard because I wouldn't have had an actual geometric sequence formula to look at like I did right here. So it would probably have been a little bit of extra work, but I would have had to do all that work to actually get my n value. But I do know it. My n value is 8, all over 1 minus 3. And if you do put that in the calculator, you will also end up with 6,560. So to do the formula with the actual S formula, the sum of the number of terms, you basically still have to know how to find a specific term in order to plug it in. Okay, let's take a look at our last question here, number 7. Even though I wrote on it a little bit, we can still read it. Ben places $500 at the beginning of each year into a savings account that earns 5% interest compounded annually. Ben would like to determine how much money is in his account at the end of 10 years. There's the key, at the end of 10 years. So basically, he's earning interest yearly, and it's compounded annually. So it's definitely a sum because he's adding from the first term to the second term, the third term, or from the first amount he plugged in, he earns a little interest, adds it to that amount, then next year earns a little more interest, adds it to that amount. So it's basically a summation. And because it has an actual rate, it's an R value, it has a common ratio. So we're going to go and do an actual geometric sequence for this also. So the first term would be how much they put in the bank, which was $500. And his rate, or his common ratio, is 5%, which is, now, if you think back to when we did actual rates compounded annually, my rate could have either been a 1 plus R, or it could have been either a 1 minus an R, depending if we were doing rate of increase, or percent of increase, or percent of decrease. We are doing increase because it's actually a savings account and you're earning more and more year after year. So it's 1 plus the rate. So my R value, my common ratio, has to be 1 plus the 5%, which if you change to a decimal, 5%, which is 0.05, comes out to be 1.05. So that's really important that you actually realize that before you actually write your formula, because it's an increase. It's not a decrease. You're increasing your value. Okay, so let's put together our formula. A sub n equals a sub 1 times r to the n minus 1. So now we have 500 times 1.05 to the n minus 1. I'm going to do a summation of this because I think it'll just be a little easier. And I'm starting at the first year. Now here's the thing. It said that they wanted to know the amount at the end of 10 years. Well, your actual rate is being placed at the beginning of each year. So like at year 1, let's write this out a little bit. At year 1, we're starting off with $500. At year 2, we start year 2, they add the interest, so we have 500 times 1.05 raised to the first power, okay, because we're at year 2. Year 3, we're going to be at $500 times 1.05 raised to the second. Okay? So we're basically off 1. So therefore, at year 10, we would be at $500 times 1.05 raised to the ninth. But they want to know the end of 10 years. Okay? So basically, that's only giving us to the ninth power. So in order to get to the 10th power, we have to do year 11. Okay? So, since it's the end of the 10th year, we need to go to year 11. Because we have to actually have our exponent be a 10. All right, so that helps with the summation because we're going from 1 to 11, because 11 minus 1 in the formula is going to give me 10. So we write the formula down, which is 500 times 1.05 to the n minus 1. We're going to put that in the calculator, and you're going to end up with $7,103.39. It didn't tell us where to round. I know it's money, so I have to go to the nearest penny. So again, we had to figure out what term we're going to. And since they said at the end of 10 years, and as I looked at it, as I went up from year to year to year, my exponent was kind of lagging behind by 1 for the year. So I actually had to go to year 11 for my exponent to be a 10, to be at the end of the 10th year to find my actual final cost. So sometimes you really have to think about things before you just plug numbers into a formula and get an answer. All right, I need you to finish whatever we didn't finish in this video, and we'll go over them tomorrow. So anything that we didn't finish from pages, let's see, 11 to 14 is your responsibility for tomorrow. I'll see you then.